meslektaşlarım, değerli katılımcılar, bugün burada Sürekli Tıp Eğitimi programımızın önemli bir parçası olan bu toplantıda sizlerle birlikte olmaktan büyük mutluluk duyuyorum. Evet, özel bir konuğumuzu ağırlamanın heyecanını yaşıyoruz. Konuğumuz tıp dünyasında saygın bir yere sahip olan Doktor İleriye. Kendisi özellikle enfeksiyon, inflamasyon ve immünite konularında derinlemesine bilgiye sahip, sayısız araştırma ve çalışmaya imza atmış bir uzmandır. Doktor Das, Hindistan'ın Hyderabad kentindeki Osmaniye Tıp Fakültesi'nde iç hastalıkları alanında tıp doktoru, yine Hindistan Ulusal Tıp Bilimleri Akademisi üyesi ve Şanslılar Latmagar ödülü sahibidir. Klinik çalışmalarının yanı sıra kanser, inflamasyon, metabolik sendrom, şizofreni ve tropikal hastalıklarda çoklu doymamış yağ asitleri, sitokinler, nitrik oksit, serbest radikaller ve antioksidanların rolleri üzerine araştırmalar yapmıştır. Güncel ilgi alanları arasında diyabet, hipertansiyon, kardiyovasküler sistem hastalıkları ve metabolik sendrom yer almakta. Doktor Das daha önce Kanada'nın Kentville kentindeki Efamol Araştırma Enstitüsü'nde bilim insanı, yine Hindistan'ın Hyderabad kentindeki Nizam Tıp Bilimleri Enstitüsü'nde tıp profesörü ve Amerika Birleşik Devletleri Syracuse kentindeki Sunny Upstate Tıp Üniversitesi'nde de cerrahi ve beslenme araştırma profesörü olarak görevlerde bulunmuştur. Şu anda da kendisi Amerika Birleşik Devletleri'nde UND Life Science LLC'nin başkan ve araştırma direktörü olarak görev yapmakta. Evet, Doktor Das, Disease and Health and Disease adlı derginin kurucusu, aynı zamanda yine uluslararası 10 derginin de editör kurulunda yer almakta. Şimdiye kadar 580 üzerinde uluslararası makalesi bulunmakta. H-indeksi 78 ve şu anda da yine Amerika Birleşik Devletleri'nde 5 patenti, 5 de kitabı bulunmakta. Şu anda Profesör Doktor Ahmet Hacı Müftüoğlu'nun TÜBİTAK 2021 projesi kapsamında laboratuvarında misafir bilim insanı olarak bulunmakta. Bugün bizlere enfeksiyonların ve inflamasyonun immün sistem üzerindeki etkilerine, bu süreçlerin nasıl işlediğini ve modern tıpta bu konularla ilgili son gelişmeleri anlatacak. Doktor Das'ın sunumunu bilgimizi zenginleştireceğini ve meslek pratiğimize değerli katkılar sağlayacağına inanıyorum. Ancak öncelikle ben Profesör Doktor Hacı Müftüoğlu'na söz vermek istiyorum ve kendisini kürsüye davet ediyorum. Ve şimdiden de bu sunum için Doktor Das'a da teşekkürlerimi iletiyorum.
Evet, ben öncelikli olarak Sevda Hocama ve organizasyon ekibi, tüm katkısı olan arkadaşlara teşekkür ediyorum. Burada değerli hocamız öncelikli olarak Umbertas Hoca bir endokrin profesörü. Burada yapmış olduğu çalışmalar sonrası kendi özel şirketini kurdu. Uzun süre birlikte devam ettirdi çalışmalarını. Sonrasında yeni ilaç denemelerine girişince bizim de etki alanımıza girmiş oldu. Yaklaşık 3-4 senedir online toplantılar yapıyorduk. Burada Erol hocamızla beraber tabii bu işte. Abdülhati hocamız, Hasibel Nabi, kendisi de Güney Kore'den transfer etmiştik 6 senedir bizde ayrılıyor. Farmakoloji çalışmalarında yolumuz kesilince bir proje kapsamında, TÜBİTAK projesi kapsamında kendisini davet ettik. Davet öncesi bir doktora tezinde, Fatma Hanım'ın doktora tezinde kendisi koautor olarak görev yaptı ve o çalışmayı bitirdi. Arkadaşımız mezun oldu. Şimdi o makalenin yazımını da bu süre içerisinde hep birlikte gerçekleştireceğiz. Bu süre zarfında diğer arkadaşlarımız sadece farmakoloji bölümü değil, klinikte de çok ilişkili olduğu için hocamız, klinikteki diğer değerli arkadaşlarımız da herhangi bir konuda onunla ortak çalışabilir. Çok sayıda dergisi var. Dergiye yayın gönderme, kendi çalışmalarını gönderebilir. Ve biz de bu konuda her türlü desteği sağlamak isteriz. Ben tabii öncelikli olarak kendisinin tanıtımını İngilizce olarak da yapmak istiyorum. Sonrasında da sunumuna başlayacaktır. Hepinize katılımınızdan dolayı teşekkür ederim. Undurti Das is an MD in the Internal Medicine from Osmani Medical College, Hyderabad, India, a fellow of the National Academy of Medical Sciences, India, and a recipient of the Shanti Svarop Bhatnagar Prize in India. In addition to his clinical work, he has conducted research on the roles of polyunsaturated fatty acids, cytokines, nitric oxide, free radicals, and antioxidants in cancer, inflammation, metabolic syndrome, schizophrenia, and tropical diseases. His current interests include diabetes mellitus, hypertension, cardiovascular diseases, and metabolic syndrome. Dr. Das previously served as a scientist at the FMO Research Institute in Kentville, Canada, professor of medicine at Nizam Institute of Medical Sciences in Hyderabad, and research professor of surgery and nutrition at Sunny Upstate Medical University in Syracuse, United States of America. Currently, he is in the chairperson and research director of UNT Life Sciences company in the United States, and consults for biotech and pharmaceutical companies in both India and United States of America. Dr. Das founded the journal Lipids in Health and Disease and serves on the editorial boards of 10 other international journals. He has over 580 international publications and ASH index of 74. 5 United States patents he has, and has authored 5 books. Currently, Dr. Das is a guest scientist in the laboratory of Atatürk Üniversitesi Vaccine Development and Application Research Center. Burada da son olarak kurmuş olduğumuz Atatürk Üniversitesi aşı merkezinin misafiri olarak çağırmış olduk. Burada da aşı çalışmalarımıza da destek olacak. Ben kendisini davet ediyorum. I want to invite Professor Das for making his presentation.
Thank you very much for inviting me to give this talk here. This is my first visit to Turkey, and hopefully this will not be the last one. So when they asked me to give a talk here, I was wondering on what topic I had to talk. Then I thought I would take a general subject like inflammation and immunity, because they occur in almost all diseases in the body. Nowadays we know that inflammation is at the root of almost all diseases, right from obesity, then to cancer, and to schizophrenia, cardiovascular diseases, and so on and so forth. So what I'm going to talk to you today is try to cover as many diseases as possible and show you what is a common thread that goes around all these diseases. So initially I'll be talking about the concepts of inflammation, a little bit about molecular biology of inflammation, and then how it is involved in diabetes, cancer, and other diseases. And it is our belief that if we understand the pathophysiology of inflammation and immunity, we will be able to develop drugs for almost all diseases, and perhaps there will be drugs that can work not just in one single disease, but in many diseases put together. So that is our concept. So now, previously we used to think that certain diseases are degenerative conditions, like osteoarthritis, then aging. But now we know that they are also inflammatory conditions, except that in these conditions, the inflammation is systemic inflammation, and it is low-grade inflammation. And so, as I outlined here, diabetes, both type 1 and type 2, then hypertension, coronary artery disease, cancer, Alzheimer's disease, dementia, depression, multiple sclerosis, lupus, all these are inflammatory conditions, except that the inflammation occurs in a specific organ or tissue, and that determines the type of disease. So the inflammation process itself is the same in all diseases, but the target tissue is different. So depending upon the target tissue, the inflammation, where it is occurring, that particular disease occurs. So based on this concept, it is our belief that we can develop probably same or similar treatments for almost all diseases. So the slides which I am going to show you today are taken from some of our work, and I have outlined here in papers. They have come very recently, this year or last year. And then from my books, which I published previously, the first book that was published in 2000 is a perinatal strategy for preventing adult diseases. We believe that all the diseases that we develop as adults occur are imprinted in the body during the perinatal period, during the second and third trimester of pregnancy and in the first 5 years of age. So the idea is to develop interventions during the perinatal period so that adult diseases will not occur. Then of course the other book is on the molecular base of health and disease, where we define what is meant by health, how health is determined by the body, and then how this can be altered, and that leads to the various diseases. Then of course we wrote a book on metabolic syndrome, pathophysiology, and how that can be interpreted and treated, and the latest renal diseases, cardiovascular diseases, and so on and so forth, except that the target tissue are different in each disease. So when you look at the origin of inflammation, it starts with infection or injury. The infection can be any type of infection. It could be intracellular or extracellular. The infecting organisms can be any microbe. And sometimes we will not be able to determine what is the infective organ or infective bacteria or microbe. So then we think that we have to search for it, and then we can find out. And once the infection or injury occurs to a tissue and inflammation starts, the body has built-in lot of mechanisms to prevent the injury that occurs due to inflammation and also resolve the inflammation. Previously we used to think that once you remove the infecting agent, automatically the resolution occurs. But we know now that inflammation origin and inflammation occurrence and resolution process of inflammation are totally different. So there are specific molecules in the body that try to resolve the inflammation that occurs. So these are called as resolvins or lipoxins and so on and so forth, and these are small molecular weight lipids. And we are trying to use these lipid molecules for the treatment of various diseases. Then you look at the molecular biological aspects of inflammation. There is infection initially to start with, then there are injury, and that leads to inflammation, and during inflammation so many other molecules are produced, and these molecules can be cellular, or then they can be the soluble mediators, and then of course there is vascular tissue that will also involve, and there is involvement of macrophages, T cells, B cells, leukocytes, and so on and so forth. And ultimately there is healing occurs because when all these processes are suppressed. And to suppress these processes, there are separate molecules in the body, and they produce the resolution of inflammation. And I will start with a slide which I saw a long time back, some 15 or even 20 years back. One of the meetings with the residents in USA when we were doing, this is a slide showing the normal young healthy American who has taken food and then fasting blood sugars and lipid molecules, and then what happens in first year, second hour and third hour. So you see that the glucose in the fasting is 82, and subsequently after eating food it increases, and at the end of 30 years, the 3 hours or 4 hours, it subsides and comes back to normalcy. At the same time, coinciding with the increase in the blood glucose levels, there is also increase in the production of insulin. So insulin, which is initially 6 moles or so, it increases to almost 30, almost 5 times increase in the insulin molecule, and then slowly it subsides, but it never comes back to normalcy, even at the end of 3 hours, even though blood glucose levels come back to normalcy. So the question that we asked at that time is, why insulin levels continue to be high, even though the blood glucose levels have come back to normalcy? And this is what you can observe in almost every normal individual. Then of course, if you look at the triglycerides, there is an increase in triglyceride levels, but there is no change in HDL, LDL, and cholesterol levels. And then alpha tocopherol levels also, there is not very much change. So this increase in insulin levels, which fails to come back to the fasting level, even after 3 hours or 4 hours, is surprising. So then we ask the question, that means at the end of 3 hours, even though the blood glucose levels are normal, insulin levels are still high. So there should be some other property for insulin to remain high. So then we thought, it may be having some action on the immune system. So we look at the generation, the expression of NF-kappa B, which is the sole gene involved in inflammation, and you find that if you don't eat any food, there is no change in NF-kappa B expression. The moment you eat food, it increases almost 2 to 3-fold is increased. And similarly, the NF-kappa B binding activity was also increased after you take the food. That means every time you eat food, there is inflammation or increased expression of NF-kappa B. Then we measured the TNF-alpha levels. They are also increased after eating food. And in individuals who are obese, when the levels are high, if they lose weight, the TNF-alpha levels fall. That means obesity is an inflammatory condition, whereas losing weight subsides the inflammation. So based on these findings, we published about 4 or 5 papers. We said that obesity could be an inflammatory condition back in 2001, almost 20 years back. We were the first to suggest that obesity is an inflammatory condition, and now it is very well accepted that obesity is an inflammatory condition. Then, of course, subsequently we extended this concept to metabolic syndrome that includes type 2 diabetes, coronary vascular diseases, and even hyperlipidemias. Then, because of this inflammation that occurs in obesity and metabolic syndrome, we said insulin is an anti-inflammatory molecule, and this we published back in 2001, and then we were the first to suggest that insulin is an anti-inflammatory molecule. So after subsequently, we produced a lot of evidence to say that it is an anti-inflammatory molecule, and we performed this study, one of the studies with our Chinese colleagues, and where we have shown that insulin inhibits tumor necrosis factor alpha production, and it also through AKT and endothelial nitric oxide synthase proliferation. That means whenever you give insulin, it not only inhibits tumor necrosis factor alpha production, but it also increases nitric oxide generation, which is a vasodilator. Whereas if TNF-alpha levels are high, it produces vasoconstriction. So that is very important. So our data suggested that insulin is an anti-inflammatory molecule because of its ability to suppress TNF-alpha. Then of course we also measured IL-6, and then it increases the eNOS expression, that means nitric oxide generation. And because of that action, insulin is a cardioprotective molecule. So recently we wrote a chapter saying that insulin is a cardioprotective molecule. Then, if these are correct, if obesity is an inflammatory condition and diabetes is an inflammatory condition, and if insulin is an anti-inflammatory molecule, then we extended this concept to say, is it possible that exercise is anti-inflammatory? Because we know that exercise is beneficial, we know that exercise prevents obesity, diabetes, so does it mean that exercise is anti-inflammatory? So one of my students in Portuguese, who is a Portuguese person, who came and he did the work in Zakat diabetic rats, where we induce obesity in them by giving them a lot of high fat diet, and then make them exercise and see what happens. And then in this experiment, we showed that when they are obese, there is increased production of TNF-alpha and IL-6, and there is a decreased production of nitric oxide and insulin resistance. So if that is the case, what else is happening in the pancreatic beta cells? So instead of just sticking to IL-6 and TNF-alpha, we did a immunohistochemistry to look at the production and the presence of IL-6 and TNF-alpha in pancreatic beta cells by immunohistochemistry. So when they are sedentary, when the rats are sedentary, there is a lot of IL-6 and a lot of TNF-alpha. The moment they do exercise, all the IL-6 and TNF-alpha that is present in the pancreatic beta cells disappears. So suggesting that the presence of IL-6 and TNF-alpha within the pancreatic beta cells is responsible for decrease in insulin production or insulin resistance and development of diabetes and obesity. Whereas when you do exercise, this IL-6 and TNF-alpha, they disappear, and so the pancreatic function improves, and exercise serves as an anti-inflammatory nature. So summarizing all these findings, we have shown that glucose is pro-inflammatory. That means whenever you eat food, you are increasing plasma glucose levels and that produces inflammation. And insulin is produced not only to suppress the increase in plasma glucose levels, but also it has got anti-inflammatory properties. So food is pro-inflammatory. So every time you eat, you are producing inflammation in your body. It is not necessary to have infection or injury. So the moment you eat food, you are producing inflammation in the body, and that's why dietary restriction is important. so that we produce less amount of inflammation. And glucose enhances IL-6, TNF-alpha, and macrophage inhibitory factor production. And insulin suppresses all these pro-inflammatory molecules. And so, the lower the blood glucose, the better. So, preferably, it should be between 80 to 100 milligrams. And exercise is anti-inflammatory, so the more exercise you do, the more benefit to the body. And then from this concept that obesity and type 2 diabetes and exercise and their relationship with insulin and to inflammation, I'll switch over to another topic where whenever there is production of infection or the inflammation, in some of those conditions, there is a cell that is produced in the body called as micronucleus. So this is a lymphocyte showing a micronucleus, small nucleus, and this is the original nucleus. This is called as micronucleus because this is a smaller nuclear material that is present in the cytoplasm. Normally, DNA is not present in the cytoplasm. So whenever there is some infection or injury, then some amount of DNA, there is damage to the DNA, and so some amount of DNA comes into the cytoplasm. And this should not be present in the cytoplasm. So when DNA is present in the cytoplasm, it becomes a micronucleus test, which you can detect in the peripheral smear. And so when this micronucleus cell appears, body tries to get rid of these cells because that indicates that there is damage to the body. And that is occurs because the cytoplasm presence of DNA is not good. So the body has developed a very good protective mechanism. So this is a molecular biology, don't bother about it. So whenever there is cytosolic DNA, then it is sensed by the cell. And thus that sense goes to the nucleus, and because of that there is NF-κB expression, and that leads to increasing production of TNF-alpha and IL-6 that produces inflammation. And that means whenever there is damage to the DNA, there is increasing production of cytokines, and that leads to inflammation. So the body has to somehow suppress this process by removing or by killing the cells which contain the micronucleus. So I'll come to that a little bit later. So then we said if micronucleus is an indication of DNA damage, how much damage occurs when a person is exposed to radiation? Because radiation is used very commonly in the treatment of cancer, and there could be accidental exposure to radiation. So we did a study where but when you expose the body to the radiation, even cancer patients who take radiation, there is increase in number of micronucleus, a dramatic increase, and that has to be suppressed. So we found that body has a molecule called as gamma-linolenic acid. That when you give, it suppresses the micronucleus production and the number of micronucleated cells. That means endogenously there are molecules available in the body which suppress the micronucleus formation and also suppress the inflammation. So we did a lot of studies, and then we looked at the gamma-linolenic acid and its product called as prostaglandin E1 on gamma radiation and chemically induced damage to the bone marrow cells, and we showed that they suppress the micronucleus formation and prevents the radiation-induced damage. And then of course this we extended to commonly used drugs like diphenyl hydantoin, which is used by many epileptic patients. They use it for lifelong, and we know that patients with epilepsy use diphenyl hydantoin for a long time. They are more prone to develop lymphomas. That is because of damage to the DNA and formation of micronucleus. So then we showed that when these patients are given gamma-linolenic acid, it suppresses the production of micronucleated cells and damage to DNA. So from where this gamma-linolenic acid comes? So our diet is rich in N6 and N3 fatty acids, and they are called as essential fatty acids, linolenic acid and alpha-linolenic acid. And these fatty acids are present in almost every diet we take. They are universal. So we never develop deficiency of LA and EA. But they themselves have to be converted into other products. So they themselves have some physiological function. They are necessary for integrity of the skin. So they prevent loss of water from the body. But they have to be acted upon and converted to certain very bioactive molecules. So LA is converted to gamma-linolenic acid by the action of an enzyme called as delta-6 desaturase, and subsequently DNA is converted to DGNA, which is a precursor of PGU1, and DGNA is converted into arachidonic acid by delta-6 desaturase to form prostaglandins. which we are all aware, because prostaglandins are potent inflammatory molecules and they are pro-inflammatory in nature. But AA is also converted into another anti-inflammatory molecule called as lipoxyl A4. So that means AA can be used to generate anti-inflammatory molecules and also pro-inflammatory molecules. And ultimately, the balance between these prostaglandins and lipoxyls determine the degree of inflammation and whether inflammation can be suppressed or not. Similarly, alpha-linolic acid by the action of same enzymes gets converted into two molecules called as eicosapentaenoic acid and docosahexaenoic acid. And EPA again gives rise to certain other prostaglandins and leukotrienes similar to which are formed from AA, but these are 3 series and these are 2 series. And they are also pro-inflammatory, but much less potent than the prostaglandins of 2 series. And DHA gets converted into anti-inflammatory molecules called as resolvins, protectives, and maresins. And DPA also gets converted into resolvins. So resolvins, protectives, and maresins are very potent anti-inflammatory molecules, and also lipoxyl A4, whereas prostaglandins and leukotrienes are pro-inflammatory molecules. So that means in every tissue, all these molecules are formed, and depending upon the exposure to infection and injury and any disease process, the balance between these pro-inflammatory and anti-inflammatory molecules is very important. If the balance is shifted towards pro-inflammatory, then it produces inflammation disease, and ultimately if the balance is shifted towards anti-inflammatory molecules, then it suppresses the inflammation and resolution occurs and we recover from the disease process. And remember that these events occur in every cell in the body, and every cell in the body has this whole synthetic biochemistry process, and so this is a very important thing. So you know, no matter in which tissue you look for, all these molecules are present, and they are very present in very small amounts in these cells, and so they are difficult to detect, but they can be detected by HPLC or by ELISA technique or by using the mass spectrometry and so on and so forth. But they are very short acting. Their half-life is few seconds or few minutes. So they have to be measured very quickly, and probably they have to measure them more frequently. I will come to that process. And then once we know that these molecules are present in every tissue, we wonder whether they are also present in pancreas. And if so, they can influence the process of diabetes. So in an experimental model where we injected naloxone and then treated the animals with all the fatty acids, the process which I have shown. And we found that of all molecules are able to decrease the incidence of diabetes, especially type 1. But of all, the most effective is the arachidonic acid. Almost no disease. So suggesting that arachidonic acid is a potent anti-diabetic molecule. Then of course we looked at what is the mechanism. We measured the plasma glucose in type 1 and type 2 diabetes, and then looked at the various levels of TNF and IL-6. I will show that. So when we give arachidonic acid, the blood glucose levels become normal, both in type 1 and type 2 diabetes. And then of course we also used a lipoxyl A4 to see whether the product formed from arachidonic acid can prevent diabetes, and we found that lipoxyl A4 also prevents diabetes. So almost no increase in blood glucose levels with AA and lipoxyl A4. So suggesting that if you have adequate amounts of arachidonic acid and if that is converted into adequate amounts of lipoxyl A4, you won't develop diabetes. So a deficiency of lipoxyl A4 and arachidonic acid is responsible for the development of diabetes. We measured these molecules in patients with type 2 diabetes, and we have shown that patients with diabetes have a deficiency of arachidonic acid and lipoxyl A4. So these results we have published in various journals, and then so ultimately the insulin resistance development and the cytokine production in type 2 diabetes and obesity, and that acting on the beta cell function and reducing beta cell function is all because of the absence or decrease in production of arachidonic acid and lipoxyl A4. So if that is the case, if these molecules are having an action, if inflammation is at the root of so many diseases, including diabetes, obesity, and type 1 and type 2 diabetes, we wonder what is happening in cancer. Because in diabetes, you want to protect the pancreatic beta cells, whereas in cancer, you want to kill the tumor cell. Can the same molecule work in both places? can it be useful to prevent diabetes and can also be useful to prevent cancer? If so, how does it so? How it is able to produce two entirely different actions. In one process, it is able to protect the pancreatic beta cells. In another process, it is able to kill the tumor cells. So, if the same process is occurring, how it is occurring? So, we did in vitro studies, mainly cell culture experiments initially, and we have shown that when you use human breast cancer cells and then expose them to various fatty acids and also normal fibroblasts, skin fibroblasts, and expose them to the fatty acids, we found that for all the fatty acids tested, gamma-aminoic acid is the best. Even though arachidonic acid also can kill, but if you increase the dose and also the duration of exposure, then arachidonic acid after some time can kill the normal cells also. But whereas GLA is very selectively kills only the tumor cells. It does not do anything to the normal cells, suggesting that it has got a very selective tumor cell action. Then we looked at the mechanism. I'm not going to look at present all the data, but we looked at mainly because it is an unsaturated fatty acid with 3 double bonds. We looked at the peroxidation process, and this is a slide showing what is called as a nitro-blue tetrazoline reaction. These are the tumor cells without fatty acid and with fatty acid, and these are the skin fibroblasts without fatty acid and with fatty acid. You see that normal cells do not produce any free radicals when you expose them to GLA. Whereas tumor cells, when you expose them to GLA, they produce large amounts of peroxides and free radical generation. That means if you give enough amounts of GLA and arachidonic acid to tumor cells, you increase the generation of free radicals and lipid peroxide formation, and they kill the tumor cells. Of course, we looked at the mechanism, how it is able to kill, and why tumor cells are susceptible but not the normal cells, and we have shown that the normal cells have the capacity to build up their antioxidants when they are exposed to redox production, whereas tumor cells don't have that capacity. And so that is why the fatty acids are able to kill the tumor cells but not the normal cells. Of course, we also looked at why arachidonic acid is having this selective action, and we found that the tumor cells are deficient in arachidonic acid, and that's how they are able to proliferate. So there is less peroxidation in the tumor cells. Whereas the moment you give arachidonic acid from outside, it is able to produce peroxidation process and kill the tumor cells. So now, based on these evidences, we are trying to develop gamma-aminoic acid as a potential anti-cancer drug. So then, of course, we verified these results in various cancer models: skin papilloma model, ascitic tumor model, and then induced hepatoma model. In all these, we found that GLA, EPA are very important, and we are able to suppress the tumor growth. And these are the publications from these studies. Then, of course, we also found that if you give gamma-aminoic acid along with radiation or with anti-cancer drugs, their action is potentiated. So that means if the combination of fatty acid and the conventional anti-cancer drugs is very important, is very active against the tumor cells. We also recently looked at the effect of these fatty acids in the presence of what is called as the monoclonal antibodies and also other drugs used against cancer. We found that their activity is potentiated. Then, of course, we went on to do an open label clinical study where we injected gamma-aminoic acid directly into the glioma in the brain in tumor patients, and we have shown that it can prevent the recurrence glioma. And then we have shown that intratumoral injections, we put a Maya reservoir and then inject the gamma-aminoic acid, and that decreased the glioma model. And so we call it as local application of gamma-aminoic acid in the treatment of tumor glioma. We have done enough of those 21 patients. So now we are performing preclinical toxicology studies because FDA wants, despite proving this, they still want preclinical toxicology studies and others. So we just completed the preclinical toxicology studies, and now we are trying to manufacture the drug under GMP conditions. So that means these biopurifiers are able to control inflammation, and they are able to control inflammation so that you don't develop obesity, diabetes, and other diseases. And at the same time, they are also involved in the pathobiology of autoimmune diseases, like for example, inflammatory bowel disease, uveitis, more severe inflammatory conditions compared to type 2 diabetes. But we found that even in these conditions, we can use appropriate amounts of the anti-inflammatory molecules and suppress them. So they are useful in many conditions, including cancer. Except that this same molecule is able to protect the normal cells but attack the tumor cells and kill them. So now coming back to the slide which I showed you previously. So whenever they are exposed to infection, inflammation, and there is a cytosolic DNA comes into the DNA comes into the cytoplasm, there is the activation of the NF-kappa B and all those things. There is production of TNF-alpha-IL-6. But the moment there is increasing production of TNF-alpha-IL-6, they have an important action. They activate an enzyme called as phospholipase A2, which is a membrane-bound enzyme. So when it activates phospholipase A2, it releases the gamma-linolenic acid from the cell membrane. And that gamma-linolenic acid and arachidonic acid that are released by the action of phospholipase A2, they get converted into either prostaglandins or to lipoxins. So if there is adequate production of lipoxins, then they suppress the NF-kappa B and so suppress the TNF-alpha-IL-6, and so there won't be any inflammation. So that means there is self-built-in mechanism in the body to suppress inflammation. So that means the same process which produces inflammation can also trigger the anti-inflammatory process. So that leads to suppression of inflammation and elimination of microinfiltrated cells. So this we have summarized in the European Journal of Clinical Nutrition and other journals, where we look at the autoimmune diseases, and then we look at the radiation-induced damage, and then gamma-linolenic acid. We performed both cell-culture studies and animal studies, and we have shown that it can prevent radiation-induced damage. What is very important here is whenever there is increase in production of cytoplasmic DNA, then that activates what is called as C-gas string system, a built-in cytoplasmic DNA recognizing mechanism. And when that string gets activated, that leads to production of interferons and cytokines. And when it occurs, there is activation of FAD, that means fatty acid desaturase, and that leads to production of PUFAs. And whenever there is increase in production of PUFAs that include gamma-linolenic acid, then they alter the metabolism and then they suppress the inflammation. So there is a very close interaction between C-gas synthesis pathway and that regulates plasma glucose levels and type 2 diabetes, and also the cancer process and inflammation. So here is a slide I am showing that when you add arachidonic acid and lipoxyl-4, that suppresses the string activation, C-gas string system, and that inhibits, and then that leads to suppression of inflammation. And at the same time, the interferon that is produced by the string pathway also acts as an antiviral state. That means whenever you have a viral infection or bacterial infection, body produces interferons, at the same time activates the C-gas system, and then activates the production of gamma-linolenic acid, arachidonic acid. So at one stage it suppresses produces the antiviral state, and at another stage it suppresses the inflammation. So both go in hand. So you are able to use, that is how your body protects you from viral infection and other infections. At the same time prevents unnatural and uninhibited inflammation. Then of course we wanted to see whether really this is very effective. So we did an experiment where we looked at the exposed animals to the lethal doses of gamma radiation and then injected them with gamma-linolenic acid, and we found that gamma-linolenic acid when you give, it increases the survival and survival of the animals. Then of course we wanted to see what is the mechanism, how this survival mechanism operates. So we looked at several cytokines, HMGB1, and then we looked at interleukin 6, and then we looked at interleukin 10 and TNF-alpha. And you see what happens is most of the time when scientists look at these molecules, they look at only one time point, either day 1 or day 14 or something like that. We thought that we should look at all the day points. So we looked from day 1 to day 14, and we find that there is a sort of an oscillation. They are increase and then decrease, increase, decrease, and then increase. So there is some sort of a celestial dance of these cytokines sometimes. Sometimes they increase, sometimes they decrease, and that process stimulates the prostaglandin system. So then we look at the COX-2 expression, then we look at the LOX expression, and then the expression of delta-6 desaturase, which is necessary for the conversion of dietary area to arachidonic acid. So you see how it happens. Initially there will be increase, subsequently there is decrease, then increase, then subsequently. So it's sort of a a dancing pattern will occur. We call it a celestial dance. So the molecules, they are not that once they are increased, they are always increased. It is not that once they are suppressed, they are always suppressed. There is a sort of a dance pattern occurs, and then same thing, enough kappa expression also, it varies from day 2 to day 4 to day 6 to day 8 to day 14. So this kind of the dancing pattern of these molecules shows that the cell is trying to produce pro and anti-inflammatory molecules at the same time in different concentrations and try to adjust a balance. And ultimately, if the balance is towards the anti-inflammatory molecules, then the resolution of the inflammation occurs. So measuring these molecules at the different stages of the disease process from beginning till the end is extremely important. So this kind of the up and down of pattern of cytokines, expression of genes, and the fatty acids is important. Then of course we are similarly we look at the lipid molecules also, PGE2 levels, then we look at glutathione levels and lipoxygenase levels. See how, and if you carefully see and compare, whenever pro-inflammatory molecules levels are high, the anti-inflammatory molecules levels are low. And whenever the anti-inflammatory molecule levels are high, the pro-inflammatory molecule levels are low. So that means there is a balance. The cell is trying to produce both pro and anti-inflammatory molecules and trying to balance and then determine where exactly the balance should occur. How much of pro-inflammatory molecules should be produced, how much of anti-inflammatory molecules should be produced at a given point of time. And that ultimately leads to the production of resolution of the inflammation. And similarly, we also looked at the expression of genes, BCL2 bags, pro-apoptotic and anti-apoptotic gene expression. See how it goes nicely. So initially the pro-apoptotic molecules are increased, subsequently the anti-apoptotic molecules are increased. So this balance between the gene expression, then the products that are produced by them, cytokines and the lipid molecules is extremely important ultimately to find out whether the inflammation subsides or not. Then of course this is just a diaphragmatic impression. So if you give the molecular fatty acids from outside, they work on 5 delta acid desaturase, COX and LOX enzymes, and then ultimately these enzymes are produced in several tissues, not just one tissue. They are produced in the bone marrow, in the intestines, and the gut, and then ultimately they lead to the survival depending upon the type of the balance between the pro and anti-inflammatory molecules. Then of course we look at the expression of genes also concerned with the lipid molecules, and they also show the same pattern, almost standard pattern, the up and down pattern, which I already showed you. And then of course ultimately if you carefully see, we also performed an experiment where we looked at ischemia reperfusion injury, which is very common during cardiac surgery, and whenever there is occlusion, especially in coronary artery occlusion. So even in ischemia perfusion also, initially there is increased production of leukotrienes, they produce inflammation, and subsequently after initial inflammation, then the inflammation is continued by perfusion E2. But then for a period of time, it starts producing lipoxygenase, which is anti-inflammatory. So initially there is inflammation, and then subsequently there is anti-inflammation, and inflammation subsides as the lipoxygenase levels are increased. So there is a telltale dance between the pro and anti-inflammatory molecules, no matter what is the disease process you take. For example, ischemia reperfusion is a non-infective condition where you are occluding blood vessel and releasing. That occurs in coronary artery disease and ischemia reperfusion injury in the gut. So that means irrespective of the type of disease you have, this balance between pro and anti-inflammatory molecules is extremely important. Of course, in these diseases we also measured various anti-inflammatory molecules, how they change with the time and how the concentrations change, their subsides increase relatively. So this balance, when looking at all the molecules is important. Looking at one molecule is not sufficient. Then of course this is showing a summary slide showing the induction of inflammation. So the inflammation occurs and then resolution. So you see how the inflammation occurs, there is initial increase in production of pro-inflammatory molecules like PGE2 and COX2 expression. And so when it starts subsiding, then the resolution process, the anti-inflammatory molecule levels are increased. So this balance between pro and anti-inflammatory molecules is extremely important. Then of course we extended these studies to COVID also, and then see what happens. And then of course we have, and others have shown, that whenever you are exposed to the the SARS virus, you should have enough amounts of hydrochloric acid. Healthy individuals who do not get COVID, they have high levels of hydrochloric acid. Whereas the people who have very severe COVID, they have very low amounts of hydrochloric acid. And when you add hydrochloric acid, then the virus is inactivated. These viruses inactivate all enveloped viruses. Then, so I am putting the diagram again. So the cytoplasmic DNA and then expressed of NF-kappa and whatever it is, or any autoimmune diseases, then increased production of proliferative cytokines, then the activation of phospholipase A2, then production of PGE to lipoxyl-4. Ultimately, this lipoxyl-4 suppresses the C-gas signaling system and suppresses the NF-kappa expression and suppresses the inflammatory process. Then of course, when you look at the COVID-infected cells, they are also eliminated by these multinuclear cells by the sepsis compared to COVID cytokine storm, suggesting that in these diseases also the levels of these molecules should be measured, and we now know that hyaluronic acid is a very important molecule that can inactivate the SARS virus and suppress the COVID infection. Then the question is, with the age we tend to develop a lot of diseases. With the age we develop obesity, type 2 diabetes, and then cancer incidence is high, and inflammatory conditions, osteoarthritis, coronary disease are high. So what is the difference between young individuals and elderly individuals? So we measured the plasma levels of pro and anti-inflammatory molecules in young and elderly individuals. In young, the levels of plasma levels of resolvins and protectins are high compared to the aged individuals. They produce less amounts of anti-inflammatory molecules. And also AA-derived lipoxyl-4 levels are low in aged individuals. In young individuals, they are very high. That's why they are healthy, and aged individuals are more prone to develop diseases. Whereas if you look at pro-inflammatory molecules, in young individuals, they are much lower, whereas in aged individuals, pro-inflammatory molecule levels are high. So that means as we advance in age, there is a balance shifted from anti-inflammatory to pro-inflammatory system in the body, and that is why with age, we tend to develop diseases very easily, and recovery also is difficult. Whereas in young individuals, because this pattern is different, and they produce more, they have the ability to produce more resolvins, more lipoxyls, and less amounts of prostaglandin A2, they are able to recover faster, and they are better than the elderly individuals in terms of recovery from various diseases. And with this summary, I would like to acknowledge some of my colleagues. This is a Hungarian group with whom we collaborate, especially in the glioma project. We have a lot of people, almost 15-20 people collaborating with us. And then we have a Chinese group collaborating with us, and this is Professor Shen and his PhD students and postgraduates. This is me. And we have Argentina group, Professor Aldo. He is at the back. He is Professor Aldo, it is me. And then his team are working with us. We work mainly with the prostaglandins and their role in various diseases. And then finally my small group of 5 students, and this is our lab. And he doing a lot of work on diabetes and fatty acids. And Sarada, who did a lot of work on anti-cancer drugs and prostaglandin cytokines. She did work on diabetes with animal models. And also she did a lot of work on neuroblastoma cells and prostaglandins and cytokines. She did all the work on, and then poorly she did all the work on radiation damage, inflammation, and so on and so forth. Thank you very much.
Thank you very much, Dr. Das. Very beautiful for your very beautiful presentation. Now, if you have any question, we get it. We can get it.
So now you see that there is a balance between pro-inflammatory and anti-inflammatory. So, and your ideas you are using like unsaturated fatty acid, uric acid. Then how about you said anti-inflammatory, for example, Resolve,
Protective
and Marseille. So how about using this, because now you said there should be a balance. In case of the pathophysiology, there is imbalance between pro and anti. So in that case, what about like increasing the anti-inflammatory by giving this natural anti-inflammatory?
Yeah. That is what our idea is. Our idea is if when there is inflammation, we have to reduce the resolution of the inflammation. So we can reduce the resolution of inflammation by giving these anti-inflammatory molecules. But remember that I have shown you slides where we measured, projectiles, resolvins, and hypoxins, and these molecules act in concert with each other. So it looks like when the resolution of inflammation has to occur, in initial stages you need lipoxin A4. And once it is triggered by the lipoxin A4 to resolve the inflammation, then that resolution has to be continued by other molecules, not lipoxin A4 alone, but by resolvins and protectins and mannitins. So it looks like all these molecules work in a very cooperative fashion. So it is not that you give only lipoxin A4 and induce inflammation, suppress inflammation. So you need other molecules also. So we are trying to understand what is the time scale. When you induce inflammation and once the resolution starts, at what point of resolution of the inflammation lipoxin A4 is produced, and at what point the resolvins are produced, and at what point protectins are produced, how they crosstalk with each other. Does lipoxin A4 trigger the production of resolvins, and does resolvins trigger the production of mannitins or not? We already did some experiments and we have shown that the resolvins trigger the production of lipoxin A4. So we already know that. So that means there is a crosstalk going on between or among the anti-inflammatory molecules and among the pro-inflammatory molecules. It is not that just one molecule produces inflammation and one molecule produces the resolution. There is a group of molecules. So how they crosstalk with each other is important. So at what time point we have to give lipoxin A4? At what time point we have to give resolvin? At what time point we have to give mannithin? And remember that these molecules are produced by different cells. For example, lipoxins, they are produced mainly by leukocytes. Resolvins, they are produced mainly by the vascular endothelial cells. Mannitins, they are produced mainly by the platelets. So that is why whenever you have infection and inflammation, there is a group of leukocytes, platelets, macrophages, everything coming together. They are coming together because they want to produce different pro-inflammatory molecules and also anti-inflammatory molecules. So that if the platelets are not there, then you don't have mannitins, and so the resolution will not be complete. And if you don't have leukocytes, you don't have lipoxin A4, and so it doesn't produce enough amount of resolution of inflammation. So all these cells are necessary, and all have to work together. It's like a society where different groups of people doing different works and finally making the society better.
Okay. Yeah, you can take the question. Professor Ahmet Kızıltunç from Biochemistry Department.
Thank you very much, dear Professor, for excellent presentation. I am curious two things about the question for you. One of them, is there a study about the cyclin-dependent kinases enzyme and inflammation relation showing in
Which one?
cyclin-dependent kinases enzyme mechanism?
Cycle?
Cyclin-dependent kinases.
Cyclin-dependent kinase.
Yeah. Cyclin-dependent kinases enzyme in the inflammation relation and cancer and diabetes. And second question, is there which one is useful? Is prevention in cancer and diabetes is polyunsaturated fatty acid? Which series? Omega 3, 6, 9, which one?
Yeah. Coming to your first question, cyclin-induced kinases. I mean, I did not elaborate, but these molecules, especially such fatty acids like arachidonic acid, because it's present on the cell membrane, every cell membrane.
Yeah.
It's present on the cell membrane, it is present in the mitochondrial membrane and in nuclear membrane. So that means they work at the local site of infection or inflammation and wherever there is DNA damage. And so I did not present this yet, but we already know that these fatty acids and their products can work on cyclins and also on the other factors. And they, in fact, when you look at the tumor cell growth and normal cell growth, one of the fundamental questions in the normal cell growth, that is that includes the cell growth, the tumor cell growth, is how cell determines to what extent it has to grow, when it has to stop growing. Okay?
Yeah.
So in a normal cell, once it comes to a certain size and shape, it stops growing. Whereas when it comes to the tumor cell, it doesn't stop. It continues to grow and stimulate other cells to grow. So when you take a cell, normal cell or even a tumor cell, and apply pressure on the cell, you produce a pressure on the cell. So the cell shape is slightly changed. That change in the cell shape is conveyed to the nucleus. And so nucleus shape also slightly changes. And that triggers activation of the enzyme phospholipase A2. That in turn triggers the generation of arachidonic acid. And that in turn gets converted into prostaglandins and lipoxins. And depending upon the type and amount of prostaglandins and leukotrienes that are generated, the cell shape changes. Cell acquires the property of mitosis, acquires the property to propagate and to grow and go elsewhere. And that holds good for normal cell and also tumor cell. In a normal cell, when it grows, it can heal the cell injury by, like, skin injury, mucosal injury, whatever it is, so that more cells are generated and they cover the wound. In the case of tumor cell, it leads to mitosis. That means fundamentally, the same physiological mechanism works both for normal cell and for tumor cell, except that, and the same molecules work, except that the way the molecules are produced, the amount of molecule that is produced, and then where they are produced and how long they are produced, ultimately determines what happens. Am I clear?
Yeah, I don't I understand you, but can you say about in the arachidonic acid? Is that central position?
Yes.
Yeah.
Arachidonic acid is at the center of all these activities. Yes. And this is surprising. When you stimulate nucleus, arachidonic acid is produced.
Yeah.
And arachidonic acid in turn determines the mitotic process and determines the metastasis and also the cell motility, and it can change the actin cytokeratin system so that the cell can move.
Thank you.
Thank you.
Okay, thank you. We can take
The second
some more
question is
questions.
asking about which kind of polyunsaturated fatty acid which is, but from where we can put arachidonic acid, like it is available commercial
Yes.
arachidonic acid,
Yes, it's available commercial,
commercial, but if we are comparing,
but not for therapy.
yes,
It is available as a laboratory, pure laboratory chemical. See, the same arachidonic acid which is available for laboratory purposes, if you want to use it in humans, you cannot use it because you have to produce it under GMP conditions, good manufacturing practice conditions, which needs very rigorous testing, and that has to be approved by the FDA. So you can't say that it is available freely, so I can use it. No, but FDA has determined that arachidonic acid comes under what is called as GRAS, generally regarded as safe. GRAS, that means generally regarded as safe. So arachidonic acid, that is why is nowadays added to infant feed formula. All infant feed formulas in European countries, Japan and USA compulsorily contain arachidonic acid and DHA. Without that, they cannot sell infant feed formula. I don't know about Turkey. So that is because our brain is rich in arachidonic acid and glucosamine acid. So for normal brain growth and development, you need arachidonic acid and DHA. And 40% of our brain weight is nothing but arachidonic acid and DHA. Okay. So such a simple molecule, which is molecular weight is about 300, is having such an important fundamental action. And we also shown, I have not shown those slides, that arachidonic acid, when it gets peroxidized, it goes and binds to DNA and to certain specific genes. And that's how it is able to regulate the expression of FAS, FAS, and then other genes. And BCL2, VAX, all genes are regulated by peroxidized product of arachidonic acid because it can go and bind to specific genes on DNA.
Professor, I remember. Can you ask about in arachidonic acid is effect of the transcript factor? Maybe you can ask in HET and GIT base function and cycling. Arachidonic acid effect of the transcript factor in cell. Transcript factor. Affected transcript factor. Transcription factor.
Which transcription factors?
Which
For
translation factor?
Yeah, for example, ATT.
Yeah, okay.
Yeah, ATT is affected in arachidonic acid.
Yeah, in fact, you know about Warburg effect, right?
Yeah.
Warburg effect, aerobic glycolysis that occurs in tumor cells. Now we know that Warburg effect can be modulated by arachidonic acid, and that's how it is able to regulate ATP generation, mitochondrial function, and respiratory burst to the mitochondria. So it has got very wide actions. Because it has got so many actions, sometimes it is very difficult to understand which action is important at a given point of time. And it has got hundreds of byproducts formed from arachidonic acid. I have just enumerated so only a few. Hundreds of molecules are generated from arachidonic acid in the body. How body is able to determine which product to be formed, how AA to be utilized for which product formation or which metabolite is still a mystery. So it is very complex.
Professor, you say something about COX-1 and COX-2. How about COX-3 and like acetaminophen? Did you do any studies about this?
COX-2.
COX-3. For COX-3.
COX-3.
Yeah. Like
Yeah.
acetaminophen.
COX-1 and COX-2, and the people believe that there is also COX-3, but still there is no complete agreement on that aspect. Some people believe that, for example, paracetamol is able to reduce the fever suddenly because it is able to act on COX-3 in the hypothalamus, but still there is no full agreement on that aspect.
Başka soru yok, öyle anlaşılıyor. Ben tüm katılımcılara teşekkür ediyoruz. Tabii öncelikle we want to thank you for your excellent presentation, and we want to thank you, your wife, Professor, Mrs. Bas, and also we want to thank you, Professor Abdülhati Hasibelnabi, for his coming lots of works. Ve bunun dışında herkese teşekkür ediyorum geldiğiniz için. Herhalde bitmeden Professor Das, please say one more thing.
Ben Sürekli Eğitimi Toplantıları Koordinatörümüz Sayın Profesör Doktor Mustafa Gül'ü hocamızın teşekkür sertifikasını vermek üzere kürsüye davet ediyorum. Şöyle ortaya alalım hocam.